Let's continue with this lecture series on kinematics and NEET PYQ. So let me move to the next problem. Our next problem over here says a car moves from any point x to y with a uniform speed vu and returns to x with a uniform speed vd. The average speed of this round trip will be how much? Okay, so let's start with our initial point, any point x over here, and let's say this is any point y over here, right? The car is moving from any point x to y. Yeah, and let us assume, let's say this distance is d over here. The separation between the point x and y is how much? It's d. Clear? Now the separation between x and y is d, and it is going from x to y with speed vu. Okay, the car is traveling from x to y with speed, what speed? Vu, and it is coming back from y to x with the speed vd, right? Yeah, vd. Great. So we have a car, it is going from any point x to any point y. The distance while it is traveling from x to y is fixed, right? Which is d. I'm just assuming d. It is coming back from y to x, which is again the same distance, which is d. It is going from x to y with a speed vu. While coming back, it is vd, right? So we have to find the average speed around the whole journey. Now we already know from our previous lecture. In case if you have not seen that lecture, you can find the playlist in the description. So here we have the average speed here, that will be nothing but total distance whole divided by total time, right? Now the total distance over here while going from x to y, that will be how much? While going from x to y, it is d, and while coming back, it is also again d. Let me repeat again. When you are going from x to y, the distance is d. While coming back, it is again d. So the total distance will be dd. And the time, now be very careful, while going from x to y, the time taken will be equals to distance d upon speed vu. Let me repeat again. When it is going from x to y, the time taken, time will be distance upon speed. So distance will be how much? D, and the speed is how much? It is vu, correct? While coming back, the time will be d upon vd. I hope this is clear. In case this part is not clear, just go through the previous video. Okay, the first video you will find I have explained in more details how we got this, right? Okay, let me come back to this. So here, when you are taking this d plus d, it will be 2d whole divided by, taking d common, we left with 1 by vu plus 1 by vd, correct? So here d and d gets cancelled, and taking LCM, you will get what? 2 whole divided by, or let me just take cross multiplication, vd plus vu whole divided by vd vu, correct? And let me take this on the top, it will be straight away 2 vu vd whole divided by vd plus vu. Okay, you can straight away here write this. Okay, in case if you already know this relation, okay, how we came up to this, you can directly remember, okay, this particular part and say that option A is correct. In case if you don't know or if you don't remember this particular relation, I have already solved it for you, right? Let's move to our next question, our question number 2. Okay, let's see our next problem. The question says the position x of a particle with respect to time t along x-axis is given by that. So let me write here, our position function is given 9t square minus t cube, right? This is our position function where x is in meters and time t is in seconds, right? What will be the position of the particle when it achieves maximum speed? Here we will make use of one concept of maths. Whenever a function is maximum, its first derivative is 0. So let's say if we have any function f of x, okay, and if this is given as maximum, its first derivative will be 0. So here in this case, it is saying maximum speed. So the derivative of speed will be 0 in this case. Let me repeat again. If you are given with any function and this function is either maxima or minima, the maxima or minima, the first derivative will be always 0. Be very careful with this. So here what is maximum? The speed is maximum, which means the derivative of speed will be 0, not the derivative of position. So first we will find the derivative of position to get the value of v. So what is v here? So v will be our dx by dt, right? That is our instantaneous velocity, and instantaneous velocity will be here, it will be how much? Derivative. Now differentiation you must be knowing this. So derivative of this will be 9 into 2t minus 3t square, right? And that will be equals to 18t minus 3t square. I hope this is clear. This is our velocity function. Now if this is our velocity function, and if we differentiate this, the derivative of this must be placed equal to 0 to get it maximum. So let me remove this whole thing, and let's write here dv by dt, and dv by dt will be equals to differentiation d by dt of the velocity function. What is our velocity function? 18t minus 3t square, right? And that will be giving us 18 minus 60. I hope this is clear. And this must be, this is our acceleration, right? And this acceleration must be equal to 0 in case the velocity is maximum, right? The derivative of first derivative must be 0. So here I am putting this as 0, and I got 18 minus 60. Taking the 60 on that side, it will be 60 will be equals to 18, and t must be equals to how much? 3. So at time t equal to 3 seconds, we have maximum speed. But the question is asking what will be the position of this particle, right? Not the time. So t equal to 3 seconds, at this time the particle was having maximum speed, right? Now if we got the time, let's substitute back to our x value here. If we substitute here at x, we get the value of maximum, at maximum speed, the position of the particle. So position of the particle x must be equals to, I'm solving over here, or let me just solve it this side. Yeah, or we can solve it here also in between. So let me solve it in between. Okay, so x must be equals to how much? So let me remove this part, okay, so that you don't get confused. X is equals to 9t square. Now substituting the value of t as 3. Why, sir, you are substituting the value as 3? Because maxima we are looking for, right? So this will be 3 3s are 9, 9s are 81 minus 27, right? And this will be how much? 4, and 11 minus 7. Here we left with 54 meters. So x is equals to 54 meter, option B. That will be our correct answer. I hope this is clear. Understood? So what we learned in this particular, these all are PYQs, okay, previous year's questions from NEET. So from this particular problem, what we learned, we understood that the maxima is corresponding to the first derivative, we must be 0. Clear? Let's see our next problem. Okay, great. Let's see our next problem. Our next question says a particle moves along a straight line OX. Fine. At any time t in seconds, the distance x in meter of the particle from O is given by. Now x is given as 40 plus 12t minus t cube. This is the position function, right? How long would the particle travel before coming to rest? So basically you are looking for the distance the particle is traveling before it is coming to rest. If something is coming at rest, its velocity must be 0. Be very careful. This is a huge difference between the previous problem and this problem. In the previous case, the velocity was maximum, and here the velocity is 0. Why? Because the particle is coming to rest. You have to understand that, okay? So in this case, what will be the 0 part? Will it be the velocity being 0? Or the acceleration being 0? It will be the velocity that being 0, right? So here it will be v, which is equals to dx by dt. Clear? And on differentiating, we get how much? We get 12 minus 3t square. And let's straight away put here velocity equal to 0. On substituting velocity being 0, this will be equals to 12 minus 3t square. And 3t square is equals to 12. And t square is equals to 4, and t is equals to 2 seconds. Be very careful, time can never be negative. So t is equals to 2 seconds. At t equal to 2 seconds, the particle is coming to rest, right? Because the velocity is being 0. If t is equals to 2 seconds, then let's substitute it back here and find the value of x. So at position x at time being 2 seconds will be equals to 40 plus 12 into 2 minus 2 cube, right? So that will be equals to 40 plus 24 minus 8, right? And that will be 64 minus 8, and that will be 56 meters. That's our displacement, right? So our x is equals to how much? 56 meters. That's option C. I hope this is clear. Understood? So what we learned in this particular problem? We learned in this particular problem that if the particle is coming to rest, its velocity must be 0, right? Let's see our next problem. Okay, great. Let's see our next problem. Our question says a car runs at a constant speed. It is moving with a constant speed. Great. On a circular track. So let us assume that this is a circular track on which the car is traveling. Okay, fine. The radius of this track is 100 meters. So let me just take this as 100 meters, our radius of this track. Great. Taking 6.28. So let me just write here R is 100 meters and time taken as 62.8 seconds for every circular lap. So every lap means, what is a lap? So one lap means if you are starting from any point A, you just travel this whole circular path and you are coming back to A, right? That is a lap. Okay, great. Okay, so let me read the question once again for you. So car runs at a constant speed on a circular track of radius 100 meter, taking 62.8 seconds for every circular lap. For every turn, it is taking 62.8 seconds. Great. The average velocity and the average speed of the car for each lap, for each circular lap. Now, if it is traveling each circular lap, it is coming back to its initial position, right? If the final position and initial position is same, what does it mean? It simply means displacement is 0, right? And in that case, if displacement is 0, let me repeat again, if the initial position and final position is same, the displacement is 0. And if displacement is 0, what will be its velocity? Average velocity in one complete circular lap. Be very careful, we are talking about one single lap. So velocity, average velocity will be 0, right? This is 0 for each lap. Clear? Now they are asking the average speed. Now average speed we have already taken, okay, many times we have taken this particular formula. So average speed I am writing here, instead of taking V, I am taking here S, and that will be equals to total distance over total time, right? I am just assuming total distance over total time. Now what's the total distance? So total distance will be while starting from any point A and coming back to A. The total distance will be how much? It will be 2 pi r, right? 2 pi r. So this will be 2 pi r, and the time taken is t, any time t. Okay. Now we are given with both of them. R also given in the problem and t is also given in the problem, right? So here it will be 2 pi. Pi is 3.14, I am assuming. R is 100 over here, and time t is given as per the problem as 62.8. Correct? I hope this is clear. Now let's simplify it fast. 2 into 3.14, it will be 6.28, correct, into 100 whole divided by 62.8. Now if you are getting confused with points, let's remove this point, put a 100 over here. Let's remove this point and put a 10 here, and this will cancel out and be left with 10 meter per second. I hope this is clear. So what is our average speed? Our average speed for this entire journey is 10 meter per second. So let me just write here average speed as 10 meter per second over here. Average velocity is 0. I hope this is clear. Let's see which option is correct where the average velocity. Okay, so first they have written velocity and then they have written speed. So here this option is correct. The average velocity is 0, and so I hope you understood why option A is not correct, right? Because they are talking about average velocity and then average speed. So average velocity is 0 and then average speed is 10 meter per second. I hope this is clear. Clear? So I hope you are enjoying this. Okay, let's move to our next problem. Okay, great. Our next problem on the screen. Our next problem says a particle moves along a straight line such that its displacement at any instant is given by S, which is equals to 3t cube plus 7t square plus 14t plus 5. Plus 5. Okay. The acceleration of the particle at time t equal to 1 second. Very simple, straightforward question. You have to find the acceleration of the particle when time is 1 second, right? So what you will do for acceleration? If you are given with the position function, differentiate it once, you will get the velocity. Differentiate it twice, you will get the acceleration, right? So let me just find velocity first. So v will be equal to ds by dt. And differentiation, now differentiation you must be familiar with. So it will be 3 3 is a 9 t square plus 14t plus 14, right? This is our velocity after differentiating the position function, right? Now acceleration A must be equals to dv by dt, and that will give us 18t plus 14. I hope this is clear. Acceleration is 18t plus 14. Now this is our acceleration function. So let me just put it here like this. They are asking now the acceleration of the particle at 1 second. So let's substitute t equals to 1 here. So A will be equals to 18 into 1 plus 14, right? And that will be equals to how much? 18 plus 14. And that will be how much? 32 meter per second square. Let's see if there is any option. Yeah, option B is correct here. Okay, 32 meter per second. That's our correct answer, right? Let's see our next problem. Great. We have a next problem here. Okay, again it's a PYQ. The position x of a particle varies with time t as x is equals to, now what is the value of x? X is equals to at square minus bt cube, correct? The acceleration of the particle will be 0 at any time t equals to, okay, let me repeat the question. The acceleration of the particle will be 0 at time t equals to, let's understand the concept here once again. The question is saying at what time the acceleration of the particle is 0, right? So first we have to find the acceleration of the particle. To figure out the acceleration of the particle, we have to differentiate this function twice, right? So v will be equals to dx by dt. How much it is? 280 minus 3bt square, right? This is our velocity function. Now, if this is our velocity function, acceleration will be dv by dt. Let's differentiate this once again. You got how much? You will get 2a minus 6bt, correct? Sir, how you got that? See, 2a is a constant, so you can take it out of the derivative. Differentiation of t is 1 and t square is 2t, so 2 3s are 6bt. I hope this is clear. So, acceleration is this. If this is the acceleration and the question is saying the time you have to find when the acceleration will be 0. So let's put here this as 0. So putting a as 0, it will be equals to 2a minus 6bt equals to 0. And taking the 6bt on the other side, it will be 2a will be equal to 6bt, right? So t will be equals to 2a upon 6b. I hope this is clear. Let's cancel out this and t will be equals to how much? A upon 3b. So the time taken here is nothing but a upon 3b, which is option B. I hope this is clear and all of you understood. Great. Let's see the next one. In case if something is not clear, you can just simply go back and watch it again. Let's move to our next question without wasting more time. Okay. Beautiful problem. Now here there is a shortcut technique also. That shortcut technique I will tell you at the end of this problem, where you can directly figure out the answer straight away, okay, without solving this typical solution. But we will first solve it using concept, because you have seen recently the NEET paper, okay, what we have seen that our questions are mostly conceptual, right? So this time direct formulas or direct techniques are not working. First you have to understand the concept behind how we got that, right? So let me come back to this problem. The problem says a car accelerates from rest at a constant rate, okay, alpha for some time, after which it decelerates at a constant rate beta and comes to rest. Great. Let's understand what is happening with a graph. Okay. So what is happening here is a car is accelerating from rest at a constant rate alpha. Okay. Now similar type of problem came in JEE. Okay. JEE means also you will find similar type of question. There they will be asking, I think, the total distance. Here they are asking maximum velocity, right? There they are finding the total distance covered by the particle. So here we will plot a graph between velocity and time. Okay. At the end I will tell you the direct two-step solution of this particular problem. So we are plotting a graph of velocity and time, right? The car is traveling with a constant rate alpha. This is alpha over here. Clear? Alpha is the acceleration. The slope of VT graph gives us the acceleration, right? So here it is alpha, and it is going from here and coming back to rest as per the problem. Let's read the question once again. A car accelerates from rest. So here it is 0. It is starting from rest at a constant rate alpha, okay, for some time, after which it decelerates. It's decelerating, right, at a constant rate beta. Let me put here beta. Okay, great. And comes to rest. So again the graph is touching the x-axis, right? The velocity becomes 0 and it is coming to rest, right? If the total time elapsed is t, so the time taken while going from here to here, let's say this is t. Great. Then the maximum velocity acquired by the car will be how much? Let us assume that at this point the car is achieving the maximum velocity. The car is achieving how much? The maximum velocity Vmax, right? And this Vmax is the maximum velocity. It will go from O to this point. Let me call this point as point P. While going from O to P, acceleration is alpha and maximum velocity is Vmax. While going from P to Q, let's say this is Q. While going from P to Q, okay, in this part of the journey, deceleration is beta, and it is coming to rest at Q, and the velocity keeps on decreasing. The whole journey is covered in time t. Clear? We have to find the value of Vmax. I hope the question is clear, right? Let's split this problem into two halves. The first half, OP, okay? While traveling from O to P. So if you are going from any point O to P, right, we can use the equation V minus U equals to AT, correct? Equation of motion. I hope you are familiar with this. Let us assume that while going from O to P, it is taking the time T1. How much time it is taking? T1. Okay, I'm just writing below this. Okay, you can write here this as split it like this and make it here T1 and make it here T2. That's fine. I'm just writing there. Okay, so I hope that's not a confusion. So V, sir, maximum velocity it is achieving, Vmax. Initial velocity, sir, 0. A, sir, alpha. T1. T1 is the time taken. I hope this equation is clear, right? You are going from any point O to P, and the maximum velocity achieved will be Vmax. That will be equals to alpha T1, and that's our T1 sitting over here, which is unknown. Vmax we have to find, so we will make use of this later on. And this is our equation number 1. I hope this is clear. Okay, let's go to the next part. While traveling from P to Q. So you are going from P to Q. You are decelerating. Your velocity is decreasing, right? So if you are decelerating from P to Q, your initial velocity is Vmax, right? I'm again using the same equation of motion. I'm putting it here in bracket, right? So what is the final velocity? So 0. What is U? Sir, Vmax was the initial velocity while traveling that particular distance. Deceleration minus beta. So why you are putting negative sign? Negative sign because it's a deceleration or retardation, right? Okay. So from here we can find a T2 is equals to Vmax upon beta. I hope this is clear. This is our equation number 2. Understood? So T2 is Vmax upon beta and T1 is Vmax upon alpha. Let's make use of this. We know that total time T given in the problem, T is a known variable, right? And T1 and T2 are unknown, so T1 plus T2. Let's substitute from equation 1 and equation 2 these two here, and T will be equals to, what is T1? Sir, Vmax upon alpha, and T2 Vmax upon beta. I hope this is clear. And T will be equals to, I am taking here Vmax 1 upon alpha plus 1 upon beta. Correct? And T will be equals to Vmax. This will be beta plus alpha whole divided by alpha beta. I hope this is clear. Let's take this bracket on the left hand side. That will give us Vmax, right? Straight away. And that was something which we were looking for, right? So Vmax over here will be equals to, how much we got? Alpha beta T upon alpha plus beta. This is our Vmax. I hope this is clear. And is there any option? Yeah, option D is the correct answer. Now this was our complete solution based on the concept. Okay, let's see our direct solution for this problem. Okay, so for this problem, let's say you are going from P to Q, O, P, Q. If you are going from O, P, Q, okay, this is alpha, this is beta, okay, and time t is given t, right? Then in such a scenario, when the velocity v here is, this should be true between velocity time graph is of this kind, right? Then in that case, okay, you should always remember that maximum velocity Vmax must be always equals to A effective into time t. Clear? What is A effective? Effective acceleration. Okay, if you look back, A effective is what? Effective acceleration. So what is A effective here? A effective here will be 1 by alpha plus 1 by beta. Okay, that's 1 by A effective. Okay, you can substitute straight away in this relation and you will get for such a kind of problem, okay, the solution. So directly you can straight away write alpha beta upon alpha plus beta into t. That will give you the maximum velocity in this case. Clear? I hope this is clear. This was our complete solution to this problem. In case if you have not understood, watch this again. So in case if you want direct solution for such problem, just remember this particular relation. Vmax is A effective into T, and A effective, how do you find A effective? 1 by A effective equals to 1 by alpha plus 1 by beta. Let's see the next problem. Great. Let's see our next problem. Our next problem over here says a particle moves along straight line such that its displacement at any time is given by S is equals to how much? T cube minus 6t square plus 3t plus 4. Correct? The velocity when the acceleration is 0. We have to find the velocity of the particle when the acceleration of the particle is 0, right? So what we will do, we will differentiate it once, okay, and differentiate it twice also to get the value of acceleration. So first we will differentiate it once to get the velocity of the particle, so ds by dt, and how much you get? So it will be 3t square minus 12t plus 3. That is our velocity of the particle. I hope this is clear. This is the velocity of the particle, right? If we differentiate this velocity of the particle, we will get the value of acceleration of the particle. So let's differentiate it once again. A equals to dv by dt, right? And differentiating this, what we will get? We will get 60 minus 12. That's our acceleration. So we have all three functions: displacement function, we have velocity function, and we got acceleration function too. Let's read the question once again and what it is asking. So the question over here says the velocity when the acceleration is 0. So let's put here acceleration being 0. So A is equals to 0. And what's our A? So it is 60 minus 12 equals to 0. Or it is 60 is equals to 12, or t is equals to 2 seconds. So at time t equals to 2 seconds, the particle is having 0 acceleration. At that instant, we have to figure out the velocity, right? So let's substitute here in the velocity function. So v is equals to 3 into 2 square minus 12 into 2 plus 3. I hope this is clear. Okay, I just substituted t equal to 2 seconds back here. So here it will be 2 2s are 4, 4 3s are 12, minus 24 plus 3. So 12 minus 24 minus 12 plus 3, and this will be equals to minus 9 meter per second, and that's option D. I hope this is clear.